So what makes us who we are? Why, though each of us has one heart, two lungs, one nose, two legs, why are all so different from each other? Perhaps it's our chemistry. Perhaps on a scale the human eyes can't see, little molecules exist in various amounts, and these molecules in various amounts are what makes each individual just that, an individual. Many factors make us who we are. Everyone is familiar with the age-old argument of nature versus nurture. Our personalities, are they genetic or manufactured by our environment? It's both. Our genes begin the process by creating the foundation that everything else will build upon. Imagine tractors tilling the soil and preparing it for growth. Next, our personalities shape the land, like growing trees and building houses shape the land. So for the first decade of our lives, our brain is nurtured into a quaint little neighborhood, ready to house our thoughts and grow with the things we learn. But then puberty hits, and our hormones rage like a hurricane. Our brains naturally adapt, however, in some cases, maladapt. So what exactly do we mean by maladapt? Does nature take a wrong turn somewhere? It's not so much that nature goes wrong, but rather modifies things for our survival. One factor largely responsible for altering our minds and our bodies is stress. Stress can be very damaging. If stress lingers indefinitely, it is called chronic, inescapable stress. Chronic stress may come from abuse or low self-esteem. So when the body is stressed, it starts to produce certain substances that will help balance itself out. One of the key substances released is called glucocorticoids. They are released from the adrenal glands above the kidneys and directly affect the brain. Glucocorticoids seem to appear almost immediately in the presence of a stressor. They are interesting because they do not linger for long, however, are potent chemicals in shaping the brain landscape. Rather than using a tractor to prepare the land, it's more like using a jackhammer. How these glucocorticoids work in the addiction equation is this. It is believed that these glucocorticoids make the nucleus accumbens sensitive to dopamine. A nucleus accumbens that is sensitive to dopamine is more likely to release high levels of dopamine easily. Dopamine is a necessary substance for our survival, but like most things, must exist in moderation. So what is dopamine? Dopamine is a neurotransmitter found in the reward pathway of the brain that is directly connected to the pleasure centers. Dopamine is also responsible for driving the primitive survival mechanisms and is particularly important when it comes to motivation and feeling good. So dopamine translates our bodily needs into physical action. It makes us do things like run and hide if we're scared, skip and jump if we're happy, or make a peanut butter and jelly sandwich if we're hungry. Dopamine also causes us to be alert, like at night, if we hear a noise and are scared. This is one of the primal survival mechanisms that keeps us from being preyed upon. Now, low levels of dopamine can also cause us to be moody and irritable. But dopamine is replenished in the brain while we sleep, so when we wake, things always look brighter and more cheerful than they did the night before. That's why they say to sleep on it. So how does dopamine come into addiction? Because it is the ever-propagating motivator to have us want more and continue wanting more. Sounds addictive, doesn't it? And for someone who is an addict, they continue to want and want. Often the desire becomes so strong it can make them do some drastic things. Why is it, though, that an addict keeps wanting? Why is enough never enough? That's a good question, and brings us to another part of our addiction equation, serotonin. Serotonin's job is to put the brakes on dopamine. It controls the amount of information the brain processes at a given time. It basically tells us when enough is enough. It tells us that we are satiated. Without serotonin to tell us we've had enough to eat, to drink, or have spent enough money, the maladaptive brain would continue in its compulsive manner to quench the cravings. The brain is basically in overdrive and there are no brakes on the car. Serotonin sounds good where dopamine sounds bad. Such is not the case, however. Without dopamine to remind us that we're hungry, thirsty, or scared, humans would have never made it into existence. Dopamine's purpose is for survival, so craving can be good. The problem happens when our wires get crossed and our maladaptive brains get confused on what to crave. Here is a good example. Take Mr. Blue and Mr. Red. Red has a relatively normal brain terrain with the right levels of serotonin and dopamine. Blue, on the other hand, is an addict. He has a nucleus accumbens hypersensitive to dopamine and low baseline serotonin levels. The two crave an ice-cold beer after work. At this point, both are craving in exactly the same way. The difference we see is after each gets what they want. Blue, with low serotonin, never feels satiated. So even when he has beer after beer, there is not enough serotonin to tell him he has had enough. On the other hand, Red wanted one beer and one beer was enough. He had enough serotonin to make him feel satiated. The conclusion here, based on neurological and clinical research, is that a brain with a nucleus accumbens hypersensitive to dopamine plus low baseline serotonin levels equals addiction.